Hello, welcome to the notes for lesson 3.6 or 3-6. This is more domain and range, and this comes from pages 32 and 33 in your notes section. Alright, so our target for this lesson is I can, given the domain of a function, determine the range of a function. Okay? Now, we've already seen that before in the previous lesson, but we're going to take what we've done and we're going to expand on it. And this is going to be something new and hopefully very challenging and exciting for some of you. But if you are having trouble, make sure you come and see me or get help from a friend or a parent. All right, here we go. So what is the difference? So when you look at these two graphs, one of them is just plotted points and the other one is the connected points, and so it forms a smooth parabola. So what is the difference? Well, this one over here, this graph, is what we call continuous. The points are connected because everything in between the points is included as well. Whereas this graph over here, we're just including the points themselves. So if I wanted to describe this graph, or this function, this set, I'm going to write out all the points. So I want you to go ahead and write them all out. So the first point, this one here, -3, -4. Then we have -2, 1. That's this one. The next one here is -1, 4. Then we have 0, 5. Then we have 1, 4. 2, 1. And finally 3, -4. And then remember to end your set with a curly bracket or a mustache bracket. Okay, so if we want to state the domain and the range for this function, for this set of ordered pairs, the domain, remember, is just all the x values. So we go -3, -2. I'll tell you what, if you want to try to do this on your own, hit the pause button and do it, and then come back and see what the answers are, and hit play again. Alright? I'm going to keep working. We got -1, we got 0, 1, 2, and 3. And then for the range, we have, remember, we don't repeat numbers and we go in order from least to greatest. So -4 is the smallest number, and there's 2 of them, but we just write 1. Then the next number is 1, 4, and 5. So domain and range, pretty easy. And I know my curly brackets are a mess. This is a roster. A roster is a list of elements in a set, separated by commas and surrounded by French curly braces. So if you look up at the coordinate pairs that we wrote above our graph, that is a roster. And this notation is roster notation, okay? So, and when we talk about these points are all included, okay? Now, when we look at the continuous graph, by the way, put some arrows here because this keeps on going. The domain for this, all the x values, now this is going to blow some of your minds, is the set of all x such that we go from -infinity up to +infinity. And we can write it using this set builder notation, or we can use our, remember the interval notation, where we write the two numbers, our two limits, the starting and the ending, and we use either parentheses or square brackets. Well, since these aren't included, it's parentheses. And then the range goes from, so it's the set of all y, where our y value goes from negative infinity again, but this time the maximum value is 5. That's this point up here. And some of you are probably wondering where the heck all this came from, and we're going to see that in just a few seconds here. So this is how you would write the domain and range for these two graphs. Make sure you copy this. You're only going to get better at this if you practice. And for some of you, this will be confusing at first. So if you didn't copy all this down, hit pause, copy it down. I'm going to move on, talk about our definitions down below. So we already talked about the roster. Now we're going to talk about set builder notation. It is a mathematical shorthand for precisely stating all the numbers of a specific set that possess a specific property. So when I was writing the domain and the range like this, the set of this is read aloud as the set of all x, so that's that first part, such that, that's that straight line that you see there. That's not an absolute value line. That means such that x is greater than 0. So it's kind of like defining our variable and then saying where the variable fits, or what the variable works for. Okay? Alright. Again, this might be a little difficult at first. We'll get better by practicing and doing more examples. So if you look on the next page, page 33, we have a couple more graphs. We're going to talk about what they mean and what they are. Okay, so the domain is all the x values. So we're going to find the domain and range of the relations. So our domain is all the x values, the range is our y values, or our f of x in this case. Alright, so I'm going to use my curly bracket. I'll do set builder first, and then I'll use the interval. So this one, finding the domain is a little easier because it's basically the biggest x value to the smallest x value. Alright, and notice these dots are shaded in, kind of like our inequality graphing. That means that these are included. Okay. So the set of all x, that's our domain, such that -5, that's our smallest value, is less than or equal to, because it's a shaded in circle, x, which is less than or equal to, look at your greatest value here, and that is 3. And I can write it using interval notation, square bracket, because I'm including everything. So -5, comma 3, and then inside square brackets, because they're included. Alright, so now for the range, I'll be using, f of x instead of y this time, because it's a function. And the set of all x, or f of x I should say. Now, for some of you, it might be easier if you turn your paper sideways and look at the greatest y value and the smallest y value. When you've gotten good at it, you will be able to spot the highest and the lowest. It takes a little practice. So the lowest f of x, or y value, is -2.1, and that's included, so it's less than or equal to f of x, which is less than or equal to our highest y value, which is 2.8. So we can write this using our interval notation, negative 2.1, comma, 2.8, square bracket. Okay, we're going to do the same thing for the circle over here. Domain, remember, is our x values. So that should be pretty easy. Look at the right side, look at the left side. The greatest number and the smallest number. So the domain goes from, it's the set of all x, and it goes from 0 to 4.2. So 0 is less than or equal to x is less than or equal to 4.2. And again, we can do interval notation, which is 0, comma, 4.2, and you do your square brackets. So finally, the range, your highest and your lowest, or if you want to turn your paper sideways and go side to side, just like you did for the other one. Again, we're doing f of x, because it's a function. Set of all f of x, such that now our lowest is negative 2.1. And that's less than or equal to f of x, which is less than or equal to our highest value, which is 2.1. Curly bracket. Now, interval notation, negative 2.1, comma, 2.1, and square bracket, because they're included. Alright? Not too bad. Well, let's take a look at another example below. Alright, so the graph of y equals h of x is given. So this is the graph. Find h of 2. So 2 is your input. The input is the domain, or the x values. So go to where x is equal to 2, go up, find where the graph is, and put a dot. So what is your y value? Alright? And your y value here, this is, your input is 2, so your output is 3. Or your range is 3. For what values of x is h of x equal to 3? Well, we just found where h of x equals 3, which is right here. So 2 is one of them. But there's another one. So if you follow this across, you'll see that the y value is still 3 here, but this time our x value is negative 3. So what values of x is h of x equal to 3? 2 and negative 3. Write the domain and range of G. That's this diagram here. Alright, so our domain, and I realize the video is getting a little long, so hopefully some of you can figure it out. Oh, by the way, this time we have open circles on the end. That means not included. Now I realize I have a bunch of stuff written up here on the paper, so if you want to write that down below, that's okay. Not included. So when you're doing your inequality or your interval notation, make sure you do not include that. Okay? Alright, here we go. So what does this look like? The domain is the set of all x, such that, now if we look, our highest value is, for x is 4, so go to this point, follow it down, x is equal to 4. Go to this point, follow it down, x is equal to negative 4. So we're between negative 4 and 4. Now notice I'm using just less than and not less than or equal to. Why? Because I have open circles for this one. And again, your interval notation, 4, comma 4, but this time it's parentheses because they're not included. Range. So our function is h of x, such that, now look at the top and look at the bottom. So the bottom is at 2. Now, we're including this, alright, because we have to. This is, we have several points that are on this, and they would be shaded in. So this one's going to be included. So it's going to be 2 is less than or equal to h of x, which this time is less than, and what's the highest point? Follow this up, and that's at 5. And that is an open circle, so that one is not also equal to. Alright, so writing it interval notation, 2, comma 5. The 2 is included, the 5 is not. Boom. Looks just like that. Okay. Determine the domain for the function for which the function is increasing. Alright, I know that we're getting long here in the video, so I'm going to kind of speed it up a little bit. The function is increasing from here to here. Okay? So, we're just writing the domain for these 3 problems here. So put D, and then semicolon. And then you're going to do your curly brackets. Now, from here to here, okay, our domain is our x value. So we're going from 1 to 4, okay? So it's x such that 1 is less than or equal to x, which is less than 4. Now, why did I not do equal to? Because I've got an open circle up here. Alright, so go ahead and do the interval for problem D. And I'm going to do the interval for E. The interval for E is 4, parentheses, 4, comma, 2, and then bracket. So this is where it's decreasing. And then I want you to try to figure out the one that's constant, the last one, F. Alright, so you're going to be doing the interval for D, you're going to be doing the set builder for E, and then you're going to be doing both for F. That's a few points on your scoreboard. I know this video is long, so there's probably going to be lots of questions. Make sure you come and see me if you need help. Good luck, and we'll see you in math.